Imagine two operating systems sitting at the foundation of modern computing, both incredibly influential, both often mentioned together, yet fundamentally different in their origins, philosophy, and development. Linux and Unix are names that have been connected for decades, and many people use them interchangeably. Some assume Linux is simply another version of Unix, while others believe Unix is an outdated operating system that Linux completely replaced. The reality is much more interesting. To truly understand modern computing, servers, cloud infrastructure, and even the operating systems that power smartphones and supercomputers, you need to understand the relationship between Linux and Unix and what actually separates them. The story begins in the late 1960s and early 1970s when computer systems were expensive. Massive machines used primarily by universities, governments, and large corporations. During this period, researchers at Bell Labs developed Unix, an operating system designed to be portable, flexible, and powerful. Unlike many operating systems of its era, Unix introduced a philosophy centered around simplicity. Each tool was designed to do one job well, and different tools could be combined together to perform complex tasks. This approach became one of the most influential ideas in software engineering and continues to shape operating systems today. Unix quickly gained popularity because it was portable across different hardware platforms. At a time when operating systems were often tied to specific machines, Unix could be adapted to run on different computer architectures. Universities adopted it, researchers modified it, and companies began creating their own versions. Over time, Unix evolved into an entire family of operating systems rather than a single product. Variants such as BSD, System V, Solaris, AIX, and HPUX emerged, each adding unique features while maintaining compatibility with core Unix principles. Fast forward to the early 1990s, and a major shift was about to occur. A Finnish computer science student named Linus Torvalds wanted an operating system for his personal computer. Inspired by Unix but unable to freely use proprietary Unix source code, he began creating his own kernel. This project eventually became Linux. The crucial distinction is that Linux was not derived from Unix source code. Instead, it was written from scratch while following Unix-like design concepts. This means Linux behaves similarly to Unix and offers many of the same capabilities, but technically it is not Unix. This leads us to one of the most important differences. Unix is a trademark and certification standard as well as a family of operating systems. Linux is a kernel that forms the core of many operating systems. When people say Linux, they often mean a complete Linux distribution such as Ubuntu, Fedora, Debian, Arch Linux, or OpenSUSE. However, Linux itself is just the kernel responsible for managing hardware resources, memory, processes, and communication between software and hardware. A complete Linux operating system combines the Linux kernel with utilities, libraries, desktop environments, and other software components. Another major difference lies in licensing and openness. Traditional Unix systems were mostly proprietary. Companies controlled the source code, development process, and distribution. Access often required expensive licensing agreements. Linux, on the other hand, was released under the GNU General Public License. This open-source license allows anyone to view, modify, distribute, and improve the code. As a result, thousands of developers worldwide contribute to Linux. This openness accelerated innovation and helped Linux spread across countless devices and industries. Cost is another area where the differences become clear. Historically, Unix systems were associated with enterprise environments and often carried significant licensing costs. Organizations paid for support contracts, certifications, and proprietary software packages. Linux distributions are frequently available at no cost. Even commercial Linux distributions typically cost far less than traditional Unix systems while offering extensive support options. This economic advantage played a major role in Linux's widespread adoption. The development model also differs significantly. Unix development has traditionally been controlled by specific companies or organizations. Changes are carefully managed through centralized processes. Linux development is far more decentralized. Developers from around the world submit patches, propose features, fix bugs, and contribute improvements. Major technology companies including IBM, Intel, AMD, Google, Microsoft, Oracle, and many others actively participate in Linux development. This collaborative ecosystem has made Linux one of the largest open-source projects in history. When it comes to hardware support, Linux has an advantage due to its enormous community and active development. Linux runs on an astonishing variety of devices. You can find Linux on desktop computers, laptops, servers, smartphones, routers, smart televisions, embedded systems, industrial machinery, automobiles, and supercomputers. Traditional Unix systems often focused on specific hardware platforms designed by the companies that created them. For example, AIX was optimized for IBM hardware, while Solaris was closely associated with Sun Microsystems systems. Despite these differences, Linux and Unix share many similarities. Both use hierarchical file systems. Both support multi-user environments. Both employ similar command line tools and scripting capabilities. Both follow comparable security models involving users, groups, and permissions. If someone learns shell commands on a Unix system, many of those skills transfer directly to Linux. Commands such as ls, cp, mv, grep, awk, sed, and command behave similarly across both environments. This compatibility is intentional because Linux was designed with Unix-like behavior in mind. One area where the distinction becomes particularly important is certification. Not every Unix-like operating system is officially recognized as Unix. The Open Group maintains the Unix trademark and certification process. An operating system must meet specific standards to be officially called Unix. Examples include AIX and certain versions of Mac OS. Linux distributions generally do not pursue Unix certification, even though they behave similarly and provide comparable functionality. Therefore, Linux is often described as Unix-like rather than Unix. Speaking of Mac OS, it provides an interesting example of the Unix world today. Apple's operating system is built upon technologies derived from BSD, Unix, and Mac. Modern Mac OS systems are officially Unix certified. This means when you open a terminal on a Mac, many of the commands and tools feel familiar to Linux users because both environments share Unix heritage. However, under the hood, the operating systems have different kernels and architectural implementations. Performance comparisons between Linux and Unix can be complicated because performance depends heavily on specific workloads, hardware configurations, and system tuning. Historically, some proprietary Unix systems were highly optimized for specialized enterprise hardware and mission-critical workloads. However, Linux has matured significantly over the years. Today, Linux powers the majority of cloud infrastructure, data centers, and supercomputers worldwide. Its scalability, flexibility, and performance make it a dominant force in modern computing. Security is another topic frequently discussed when comparing Linux and Unix. Both systems were designed with multi-user security in mind, a feature that originated long before personal computers became common. User permissions, process isolation, and access controls are deeply integrated into both environments. Linux benefits from continuous scrutiny by a global community of developers and security researchers. Vulnerabilities are often identified and patched rapidly. Traditional Unix vendors also maintain strong security practices, especially for enterprise customers, but the processes are generally more centralized. The rise of the Internet dramatically increased Linux adoption. As websites, online services, and cloud platforms expanded, organizations needed reliable and cost-effective operating systems capable of handling massive workloads. Linux fit these requirements perfectly. Its open-source nature allowed companies to customize systems according to their needs without expensive licensing restrictions. Over time, Linux became the backbone of the Internet. Today, a significant portion of web servers, cloud platforms, and enterprise applications run on Linux. Meanwhile, traditional Unix systems found themselves serving more specialized roles. Industries such as finance, telecommunications, government, and large-scale enterprise computing continued using Unix platforms because of their proven reliability and long-term support. Many organizations invested heavily in Unix infrastructure and continued operating those systems successfully for decades. Even today, certain mission-critical environments rely on Unix platforms due to established workflows and specialized applications. The philosophical difference between Linux and Unix may be just as important as the technical one. Unix emerged from an era of centralized computing, controlled development, and proprietary systems. Linux emerged during the rise of open-source collaboration and global software communities. Unix influenced Linux's design, but Linux expanded those ideas into a worldwide movement that transformed how software is developed and distributed. For new users entering the technology world today, Linux is generally far more accessible. Anyone can download a Linux distribution, install it on a personal computer, explore the source code, and participate in the community. Learning resources, tutorials, forums, and documentation are readily available. Traditional Unix systems are often encountered in enterprise environments rather than personal computing settings. In the end, the real difference between Linux and Unix comes down to origin, licensing, development, and certification. Unix is the original operating system family that established many of the concepts still used in computing today. Linux is an independently developed Unix-like kernel that adopted those concepts while embracing open-source collaboration. Unix laid the foundation, and Linux built upon that foundation to create something larger and more accessible than anyone could have imagined. Without Unix, Linux likely would not exist in its current form. Without Linux, modern cloud computing, containerization, web hosting, Android smartphones, and countless other technologies might look completely different today. Rather than competitors, Unix and Linux are part of the same evolutionary story. Unix provided the blueprint, while Linux democratized the ideas and brought them to the world. Understanding that relationship reveals why these two names continue to shape the future of computing decades after their creation, and why the debate between Linux and Unix remains one of the most fascinating topics in technology history.